I don't think I'm exaggerating. It's all about this fork. My problem is due to my double-decker utensil tray. As the forks are packed randomly in the tray, every so often the tines catch on the upper lid when the drawer is closed. This is typical of one of my forks after several years of drawer abuse. Now I have CATIA 3DExperience and a 3D printer, so I can fix this problem. To do this, I'll use CATIA 3DX to design this tray insert that I will 3D print. Note the two humps shown, as well as the tapered ends for each compartment. These features will force my kids, on the rare chance they unload the dishwasher, to put the forks in with the tines pointing down, so they no longer catch on the drawer opening. Genius, eh? For step 1, I just trace the outline of a good fork from two directions and measure the controlling points using a ruler and a caliper. Using Sketcher in part design, we enter all the points we measured using their XY coordinates. We could try to make a continuous spline through all the points. Don't do that. Because the contour varies so much, we would need to add many more control points to make it conform to the shape we need. Also, it's very difficult to make a multi-node spline straight, and the line sides of our fork are definitely straight. A much better way is to break it up into lines and curves. In this example, we have a circle for the end, a gradual spline for the middle, and 3 lines for the business end. Using corner and trimmer limiting, we modify the geometry to look like half a fork. Mirroring the geometry about the x-axis will give us a top view of the fork outline. Exiting the Sketch app gives us the profile in 3D space. We then enter the fork side points on a new sketch in a new body. In this case, we can string all the points in a single spline, as it is a gently undulating curve. We then offset the curve 80 thousandths and join the ends with lines to close the contour. Exiting the sketch, we can see two profiles at 90 degrees to each other. Using the sketch and body we just created, we make a mirrored pad larger than the fork width. Making the other part body the in-work object, we make a mirrored pad that is taller than our fork using the first sketch. Using a Boolean operation, we create an intersection of the two bodies to get the solid shown. Using a pocketing feature and patterning it up and down, we get the tines. For step 2, we'll create a product named Fork Tray Assembly, containing a part named Fork Tray. Inside the part will be a 3D shape we also name Fork Tray that will actually contain our design that we will 3D print. This is one of the areas where 3DX differs from V5 in the spec tree architecture. We'll start with a sketch that is 30 thousandths smaller than the compartment currently holding the forks. We then make a pad with the sketch that is the height of the compartment and use the shell command to make the walls 0.025 thick. The next step is to insert two part instances of the fork and constrain it to the floors and walls. Using assembly pattern, we can quickly insert multiple new fork instances in the vertical direction to simulate the actual drawer condition. Editing the fork tray 3D shape, we add a new sketch at the top and create a bisecting line for our stiffener. A new feature in 3DX is you can create a stiffener 90 degrees to the sketch plane. Then, using a sketch plane off a vertical wall, we make our foolproofing bump and make a corresponding pad for that pocket. We repeat this for the other side. Finally, we fill in both ends with a radius adjoining the spoon end. After saving everything on the web using Inovia, We then resave the 3D shape as an STL. We then read in the STL into my Cura software, change my build plate adhesion to brim, and slice it. We then transfer the G-code to my Creality printer. Here the printing has been going on for a bit, but you can see the infill for both the bumps and the pocket ends. And here's the completed printed part. The brim you see makes it easier to remove it from the glass plate. Here is the part cleaned up with the brim removed. It fit perfectly in the existing compartment. The forks loaded perfectly. The bump only allows one fork to be loaded before the user realizes their mistake. It's way easier to load it the right way. And the taper won't allow forks to be loaded in the wrong direction. As I had 2 compartments for forks, I printed another one that night. As you can clearly see, pending disaster was averted, and my kitchen was saved from almost total ruin, using a little bit of ingenuity and CATIA 3DExperience. Are you interested in learning CATIA 3DExperience? XDT Software has developed an amazing simulation method to actively engage you in learning CATIA. All 3 button positions and locations of your mouse are recorded by our software to determine if you perform the sequence correctly and can progress to the next frame. In this frame, you follow the instructions here, or the mouse icon here, for the correct button sequence. Then slide your mouse from the green arrow to the red arrow and release your buttons at the red arrow to simulate a zoom, just like in CATIA. Note that we were on frame 13 and now frame 14 out of 40 frames for this class. Also note that we have registered 2 errors so far due to a bad mouse position or mouse button combination. You must get at least 80% correct to get credit for the module, but you are free to redo it again as many times as you'd like. Anyone can try a sample of our training for free. Go to www.3dextrain.com and click on Free Test Drive. Fill out the info and click Submit, and you get an email with download instructions from support@3dextrain.com. Be sure to check your spam folder. Using the link provided, download our software to your PC, and you can try 4 of our 35 modules for CATIA 3DX Design Essentials. If you'd like to take the full class, contact one of our partner colleges here. Class cost is $2,200, but they will take company training vouchers, Trade Adjustment Act, and other retraining program funds. If you are currently unemployed and don't qualify for those programs, we have a special of $300 for our CATIA 3DExperience Design Essentials class. Contact us directly at 206-793-3491 or email us at kai@xdtsoftware.com to arrange it. We hope we can help you in your future career.